All right, hello everyone. Welcome to my channel, and this is an educational channel. We try to look at important theories of everything, at least important to me. They've been important to my life, and I'm hoping that they'll be important to yours if you can get into it. So just give it a try. We look at different all-encompassing views and magnum opuses from obscure crackpots. And today is our 366th video on the reciprocal system of theory from one Dewey Bernard Larson. And Mr. Larson was an engineer that worked in America, out west, in Portland, primarily, in the 20th century. And he was born in 1898, died in 1990. About 1930, he started having his first epiphanies about the reciprocal system. Took him about 25, 30 years to develop his ideas, put out his two fundamental postulates in 1959. And then from those postulates, he derived, through a process of deduction, a theoretical universe about, what would what would this reciprocal system universe look like if his postulates are correct? What would be the, ramifications of that? And then in his books, which he wrote many books starting in 1959, all the way up until his death, and even one book came out posthumously, he more or less compared his findings, his theoretical findings, with the empirical findings of the legacy scientists, particularly, the measurements that they made in their laboratories, and different findings that they've made. Also some theoretical stuff. And so it's interesting to find how Larson is able to, in many cases, come up with the exact same, you read the scientific tables about, say, something having to do with the periodic table, the melting point of different elements. And Larson is able to basically reproduce the tables strictly from theory, not from measuring it in a lab. And in many cases, when he has a dispute, when he comes up with an answer that they didn't come up with, he is able to demonstrate how his answer is correct. Or at least why there is this discrepancy. Now, the basic idea behind the reciprocal system, again, is articulated in his two fundamental postulates. The first of the two postulates is much more important and fundamental, and that is that we live in a universe that is composed entirely of one component, which is motion. And motion exists in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. And so that's the basic first postulate. Second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. The second postulate has been contested by some of Larson's followers, including Dr. Bruce Peret, who prefers to use his postulate. Dr. Bruce Peret came up with what he calls RS2, the re-evaluation of the reciprocal system, which is basically an attempt to be in the spirit of the reciprocal system, but to tweak a few of the things that maybe Larson didn't know about, or things that maybe need to be updated. Larson certainly knew about non-Euclidean geometries, but I don't think he was really up on it. And he's been quoted as really saying that, well, yeah, I could use these non-Euclidean geometries, but it would introduce things that are even more complicated, and it would just complicate the whole situation. But it appears as if Dr. Peret, by using projective geometry rather than Euclidean geometry, and by using non-commutative mathematics and non-primary magnitudes, was able to actually simplify the system by quite a bit. Not so much in the physical realm, but in the metaphysical realm. Some of Larson's postulates, Larson's first two postulates, don't really apply to the metaphysical realm. And Larson had to propose 4 new postulates for the metaphysical realm, the, things having to do with beyond the physical, the mental and the ethical, the religious. He had to come up with 4 new postulates, but when Dr. Peret is able to change that second fundamental physical postulate, he no longer needs those 4 metaphysical postulates. So that's kind of a story for a later time, or we've already kind of told that story a little bit in a past episode, maybe a month ago or something. But what we really want to focus on is that first postulate. The universe is made out of motion. Motion is the relationship between space and time. That basically creates a reciprocal relationship between space and time, and that basically means that motion is a fraction, with space or time as the numerator and time or space as the denominator. And all forms of your scientific quantities, whether it's speed or energy or mass or acceleration or force or capacitance or electric charge or magnetic flux or viscosity or fluidity or pressure, these are all fractions with time or space as the numerator and space or time as the denominator, with either one of them being potentially in multiple dimensions. As Larson says, the universe is made out of motion. Motion exists in 3 dimensions. Now, one thing that I have trouble with in that first postulate is that he talks about how what we're talking about is motion. But in Larson's formulation, I wish he would have used, and I'm sure there was a good reason why he didn't, but I haven't quite seen it yet. Actually, when he first came out with his postulates, this is another important point, is that Larson revised his postulates several times over those last 30 years of his life. And so it's difficult to quote the postulates because you need to specify which time period you're talking about. When Larson first proposed the postulates, he didn't call it motion, he called it space-time. And then toward the end of his life, he began to think of it more in terms of change in 3 dimensions. So, I just wish he would have used an adjective with motion that would be scalar motion or progressive motion or non-local motion. Because he's not really referring to motion the way that most scientists might think about it in terms of velocity. That is a motion that has a direction. He's thinking about it as a scalar motion, which is a motion that has no direction or no specific direction. Has a magnitude, but no direction. And you envision this using a balloon with dots on it. If you blow up the balloon, all the dots are moving away from each other. All the locations, in fact, are moving away from each other, not just the dots, but every location on that surface of the balloon is moving away from every other location on that surface. The further away they are, the faster they're moving away from each other. And this is, more characteristic of a scalar motion. Scientists know about this kind of motion, but they don't recognize its significance. They've never given it any significance, even though they have looked through their telescopes and have discovered that all of the distant galaxies are moving away from each other. So they know that it is a real physical phenomenon, but have not really attached any importance to it. Larson puts it at the center of his theory, and one significant part of this is that it turns out that the way that we think of fields kind of goes away. If you suck in the balloon, all the dots are moving toward each other. And that's analogous to something that Larson would call gravitation. But there's no gravitational field. All of the dots, all of the locations are moving toward each other. But like one isn't being attracted by another. There's no field. There's no medium necessary. There's no field necessary for one to go toward another. The only way that that happens is when you arbitrarily decide that one of the points, one of the locations is stationary. Then when you decide, when you assign a reference point, then you can start identifying the directions, and that's when the concept of a field comes in. So that's one aspect of it. The other is the three-dimensionality. Okay, so that is what Larson calls clock time and clock space. The clock is always getting later and later and later, but in no specific direction. Space is always getting farther and farther and farther apart, but in no specific direction. Clock time and clock space, that refers to that progression or that scalar motion. And then he says that they are in three dimensions. He refers to this as coordinate space and coordinate time. And this is coming from his observation of coordinate space. We see space as more or less being three-dimensional with XYZ coordinates. We see volume, and because space and time are reciprocals of each other, generally we think of reciprocals as having the same qualities. So he is more or less extrapolating that, okay, if space has three dimensions, that means that time also has three dimensions because they have the same qualities as being reciprocals of each other. So he calls that coordinate time. And then he also has the concept of discrete units. Space and time and motion as the relationship between space and time come only in discrete units. There has to be a minimum unit of space and a minimum unit of time before you have either one of those quantities. And really that space and time do not exist in and of themselves. They only exist together in motion. And when you have exactly 1 unit of space in 1 unit of time, you have the speed of light. And for Larson, the speed of light is what he calls unit speed. That is the background motion of this universe. So if you have a state of rest in this universe of motion, you have motion outward at the speed of light in all directions. That is what Nehru, one of Larson's other followers, calls a featureless uniformity. So we see the progression of the natural reference system moving outward in all directions at the speed of light as absolute nothingness, which makes sense in a universe of motion. If you have a universe of motion, there is a prevenient motion that exists before everything else. And so this progression of the natural reference system, this outward motion at the speed of light, is the background, or the 0 point, or the null point, or the reference point. Measurements are made from that datum, not from zero, which is what the legacy scientists measure from. Okay, just like to get into this article here. This is the fourth installment. So if you want to go back to the start, you want to go back to 3 videos. And this is from Dr. Bruce Peret, and it's one of his RS2 articles introducing his reevaluation of the reciprocal system. And this is an article called Dimensional Thinking. Now, just wanted to preface this. In the reciprocal system, there are scalar dimensions, and then there are spatial dimensions, and I guess temporal dimensions. It takes 3 dimensions of space to describe 1 scalar dimension. There are 3 scalar dimensions. The other 2 can only be partially described. And now what Peret is trying to do here, he's trying to use complex numbers, in particular quaternions, which is a combination of a scalar 1, which is like the progression, and then I, J, and K, which are your imaginary operators, which are basically 90-degree rotations. And this is what he's using to try to attempt to describe, especially atoms, but other phenomena as well, photons. Okay. This quaternion structure also provides a more accurate definition of the photon. In quaternion math, 2D rotation of I dot j is equivalent to 1D rotation of k. I dot j equals k. If I dot j is paired with a negative k rotation, you end up with a k negative k, which equals positive 1. 2 counter-rotating systems, which is one of Nehru's conventions or revisions of Larson, called the birotation. Larson thought of the photon as being a combination of a translational motion and a vibrational motion that creates a sine wave. Nehru is creating his sine wave using a birotation, 2 counter-rotating systems. Larson didn't conceive of that because Larson felt that rotation was not a primary motion, that you needed to have something to rotate before you could start rotating. But Nehru and Peret are both claiming that you can have that rotation is every bit as primary as translation or a straight line motion, and that vibration is actually only the result of an interference between rotating motions. So 2 counter-rotating systems producing a cosine wave that has a net outward unit speed in space, a wave traveling at the speed of light. Nehru's birotation has 2 one-dimensional electric rotations that reduce to a cosine wave in space. The quaternion model has a 2-dimensional magnetic. So now, Peret is actually revising Nehru's work on the birotating photon, or he's tweaking it. He's wanting to use a quaternion rather than two one-dimensional electric rotations. Normally in the reciprocal system, whatever is electric is one-dimensional, and whatever is two-dimensional is magnetic, and then gravitation would be the three-dimensional. The quaternion model has a two-dimensional magnetic rotation coupled to a one-dimensional electric rotation, making the quaternion photon electromagnetic radiation solely from its structure. As such, it would also have various orientations, resulting in the various transverse photons modes, which are not a consequence of Larson's or Nehru's models. Thinking in three dimensions has produced an improved model of Larson's units of motion and of Nehru's birotating photon, but division algebra supports 1, 2, 4, or 8 dimensions. So what happens if we start to think in multiple dimensions, like the aliens in Haddon's comment starting this paper? We can still hard code a three-dimensional universe, but by applying a variable number of units of motion per dimension, a mathematical system evolves that accurately represents all of the known motions in the reciprocal system, which is unique in that it includes life as a natural consequence of motion. The one-dimensional real numbers represent the outward expansion of the universe at unit speed, the speed of light. This unit of motion, though used in the reciprocal system frequently, was never defined as a unit of motion. So that is the first number in a quaternion, the scalar, the number that has no I, J, or K component. The two-dimensional complex numbers represent a single electric rotating system, electrons and positrons. The four-dimensional quaternion represents Larson's double rotating system that forms the basis of particles and atoms, and electromagnetic in nature. Quaternions model the photon and neutrinos. And then I would also guess matter too. The eight-dimensional octonion represents an interlinked structure of double rotating systems that are the mathematical model of a screw, vortex, or helix. These structures are basic to life units, such as the helix of the protein. I think that's can't remember what Greek letter that is. The octonion can be considered the particle version of a living cell. Each of these dimensional algebras can exist in either a single or dual form, such as a pair of quaternions that are joined with the epsilon function that keeps them separate, yet interlocked. This duality creates the remaining rotational structures of the reciprocal system as they work cooperatively. Dual complex forms the birotation necessary for the vibrational motion of charge. Dual, he means dual complex numbers. Dual complex numbers form the birotation necessary for the vibrational motion of change. And then Um, dual quaternions are the two double rotating systems that form atomic structure, starting with the proton. Okay, so the quaternion models the photon and the neutrinos, but the dual quaternion models atoms. Whereas the dual complex number models electrons and positrons, and the single complex number models electrons and positrons, but the dual complex number models charge. Dual octonions express the life unit, the biological cell, linking the material and cosmic structures together, combining the linear motion of space with the rotational motion of time. So how does that differ from the octonion? The 8-dimensional octonion represents an interlinked structure of double rotating systems that are the mathematical model of the screw, vortex, or helix. These structures are basic to life units. So the octonion can be considered the particle version of the living cell, but the dual octonion express the life unit, the biological cell, linking the material and cosmic structures together. I'm not exactly sure what the difference is. He says the biological cell. Up here he says the particle version of a living cell. Not sure. Okay. By using a combination of division algebras, dimensions to express Larson's units of motion concept, all the rotational structures, both material and cosmic, can be mathematically represented with real numbers, complex quantities, quaternions, and octonions. This solves many of the problems with trying to use fixed dimensions and units, creating a very concise mathematical progression of complexification from the unit speed motion of the progression of the natural reference system all the way up to the biological cell of the life unit. Okay, that is the end of this paper, and this is something that I'm going to need to go over and try to understand what he's talking about. I'm currently trying to read an article about division algebras. I don't have a firm grasp of that, but it is an interesting way to do it. Larson's way of kind of doing matter and charge and life is a bit cumbersome, and so if Peret's model is usable, it would be a big advance, I would say, because it's not that again, it's not really that Larson is wrong. It's kind of just that his methods need to be tweaked a little bit, and for good reason. You know, I mean, he's one dude that's trying to come up with a whole theory of everything. It's more a bigger job than one person can do in one lifetime. And he did a fantastic job with what he did, but he definitely left some, some things undone. And he admitted that in his life. He said, I believe that the theory itself is correct. You know, whether I've applied the theory correctly in all cases is a different question. And that my mistakes will eventually kind of come out in the wash, and other people will hopefully be there to, resuscitate these concepts and put them into a better format. Okay, so don't know exactly where we're going to go tomorrow. This is the end of Bruce Peret's 9 articles on a reciprocal system 2. I might try to dig into some of Peret's other stuff and see if I can find any things that might shed more light on the reciprocal system 2, because I think that's kind of what we're going with moving forward. Now, there are a few people out there, including Dr. Ron Satz, who I believe is still alive, who are more orthodox Larsonians. They think that Larson, got it right, and we need to work from where he was. And then there are some people that are, I would say, more wildly speculative, who are like, we need to just, revise this. And I'm leery of those people because I don't feel like they really know Larson in the first place, and so it's hard for me to accept their corrections of Larson because they don't know Larson well enough to know whether he got something wrong or not. I feel like Dr. Peret and Dr. Nehru are on really firm ground with understanding Larson. In fact, I feel like they're the two people who understand Larson the best. And they are, when they make changes, I listen more intently. Okay. But then again, I know pretty much jack about this. I've been studying it for a while, but I'm a slow learner. I know it's important, but I'm not exactly sure how it all fits together. So this is an important paper for me, at least, and hopefully I can pass some of that on to you. Hopefully some of you can pass it on to me if you understand it better than I do. Okay, well, thanks for tuning in today, and we'll be starting up something new tomorrow. Have a great day.